Okay, let's dive right into this, because honestly, the world is changing faster than most of us can even process. Since antiquity, humanity has had this grand, almost mythological dream to create machines in our own image. Machines that are smart, machines that can actually think. And suddenly, it feels like we've woken up and that dream is just our everyday reality. We're looking at technology that is capable of spotting microscopic cancer lesions years before a doctor can, seamlessly faking a presidential address, and even allowing a person to command a bionic arm just by thinking about it. So today, we are going to unpack the reality of artificial intelligence in this explainer. We're going to cut through the science fiction to show you exactly how this technology works under the hood, what it means for our future, and how we're actually building a partnership with these extraordinary machines.
To cut through all those overwhelming buzzwords, here is our roadmap. 1. The artificial intelligence dream. 2. How neural networks actually learn. 3. Supercharging medicine and science. 4. Deepfakes and manipulated reality. And 5. Keeping humans in control. Section 1. The artificial intelligence dream from concept to reality.
Something massive has shifted when you stop typing rigid search terms and start having a fluid, natural conversation with a machine. It's exactly like researchers did in the source material with an AI assistant named Pi. The interaction just feels alive, learning through interactive dialogue. But to see how we got here, you really have to look at the staggering acceleration of it all. Back in the 1950s, Alan Turing proposes the Turing test, basically asking if a machine could converse so well that it's indistinguishable from a human. For decades, it was just theory. Then, in 1997, IBM's Deep Blue defeats chess grandmaster Garry Kasparov. Jump to 2016, and DeepMind's AlphaGo defeats a world champion in the incredibly complex game of Go. And then, bam! 2022, ChatGPT goes viral globally. We went from pure theory to an absolute explosion.
Section 2. How neural networks actually learn under the hood.
So how exactly did we get from playing chess to generating original poetry? Well, the major shift was moving away from classic AI. Things like Deep Blue were brittle, rule-based systems. They just analyzed 200 million programmed paths a second to find the best move. It wasn't actually thinking. Modern neural networks, however, are modeled on the 80 billion neurons in the human brain. They don't follow hard and fast rules. Instead, they take in massive streams of data, recognize patterns, and adjust the weights of their connections based on success or failure. It's called reinforcement learning, and it's honestly a lot like training a dog. You allocate a reward for good behavior, and the connections that lead to success get strengthened, just, with a lot less shedding and fewer treats.
Let's crack open the black box of what we call convolutional neural networks, or CNNs. Step 1. The system combs through a picture using thousands of virtual magnifying glasses, basically looking for basic puzzle pieces like an edge here or a texture there. Step 2. It repeats this on larger and larger sections, assembling simplified versions into a puzzle until it makes a guess, like is it a dog, a cat? But step 3 is where the real magic happens. Through a process called backpropagation, if the guess is wrong, the label data is sent back through the system to correct those previous operations. It literally adjusts its own artificial brain so the next time it guesses, it's smarter.
Section 3. Supercharging medicine and science, the life-saving upside. Now, this pattern recognition isn't just some abstract theory. It is generating miraculous, tangible applications right now, actively overcoming the Achilles heel of the human eye. Take a look at Mirai, designed to predict breast cancer, and Sibyl, designed for lung cancer. Radiologists are brilliant, obviously, but the human eye simply cannot perceive the incredibly subtle early patterns of a developing precursor lesion. Because they were trained on hundreds of thousands of scans, Mirai can predict a future breast cancer diagnosis within 5 years at up to 84% accuracy, and Sibyl can forecast lung cancer with up to 95% accuracy. It's seeing things years before a human clinical diagnosis is even remotely possible.
And the scale doesn't stop at radiology. Look at this number, 200 million. This is the staggering scale of a program called AlphaFold, developed by DeepMind. Using the exact same pattern recognition principles we just talked about, AlphaFold successfully predicted the three-dimensional structures of 200 million proteins. Guys, that is nearly all the proteins known to science. By understanding how a protein is shaped, scientists can figure out how to disable it if it's causing a disease. It's an absolute game changer.
Which actually leads us perfectly to this awesome analogy from computational chemist Petrina Kamya. She describes using generative AI in drug discovery as being like choosing an Airbnb. Instead of manually trying to build a molecule from scratch in a lab,
You just plug your molecular criteria right into the algorithm. It's just like filtering for the number of bedrooms or a specific location on a rental app. The generative algorithm filters down the options and outputs the absolute best molecular candidates in a matter of hours. And here's why this matters so much. We are literally condensing years of traditional drug discovery timelines into a single afternoon, making it radically cheaper and allowing us to finally target neglected diseases. And, science isn't just about medicine. AI is tackling the climate crisis, too. A system called Alert California uses a neural network that constantly monitors petabytes of video pouring in from mountaintop cameras. Before a human dispatcher could ever possibly notice, the AI spots the tiniest anomaly, just a tiny hint of microfire smoke. Cal Fire can then orchestrate a lightning-fast response, meaning potential megafires get nipped right in the bud. These are the catastrophic fires you never end up hearing about on the news, all thanks to an artificial brain standing watch.
Section 4. Deepfakes and manipulated reality, the dark side.
But hey, we gotta look at the whole picture here. It is time to move past the Hollywood Terminator tropes and look at the immediate, very real danger of AI-driven disinformation. To really grasp the threat, you have to understand the mechanics. Early deepfakes were powered by what's called a generative adversarial network, or GAN. Think of it as a dizzying loop between a student and a teacher. The generator splats down a bunch of pixels to try and create a fake image. The discriminator, which has already analyzed millions of real images, looks at it and says, nope, try again. It rejects it over and over in an adversarial loop until the image looks flawlessly real. This is exactly the tech behind that famously eerie, incredibly convincing video from 2018, where comedian Jordan Peele used his impression to puppeteer a fake video of Barack Obama. And remember, that was years ago. The technology has only accelerated since then. As computer science professor Haney Farid states so perfectly, we have lowered barriers to entry to manipulate reality. To prove it, Farid took just 90 seconds of Zoom audio from an interviewer and almost instantly generated a flawless audio deepfake. He dubbed it the Mylinator, and it could say whatever he wanted it to say. The skill required to do this used to be limited to a handful of people on Earth. Now, almost anyone can do it.
And the stakes here are absolutely massive, $500 billion. In May of 2023, a single AI-generated fake image appearing to show a bombing at the Pentagon was shared online by a seemingly verified news account. In just minutes, the stock market dropped by $500 billion. Whether it was an intentional market manipulation or just some terrible prank, the financial and societal impact of that is just breathtaking. So how are today's fakes made so ridiculously convincingly? Today, we use diffusion-based models. And this is baffling, but it's brilliant magic. Step 1. The AI vacuums up billions of captioned images from the internet. Step 2. It deliberately corrupts those images with static noise, doing this 6 billion times until the image is completely unrecognizable. Because it learned exactly how to destroy the image into pure noise, Step 3 is where it reverse engineers that process. It takes a field of pure static, and based entirely on your text prompt, it mathematically reverse engineers it down to the pixel to create a photorealistic image of something that never even existed. Which leaves us staring down a pretty critical question. In a world where literally anything can be manipulated with such ease, how are we supposed to know what's real anymore? We already live in an ecosystem built on distrust of media and institutions. Adding flawlessly manipulated AI video and audio evidence into the mix is, as one expert brilliantly called it, throwing jet fuel onto a dumpster fire of societal mistrust. Section 5. Keeping humans in control, the partnership. So where does all this leave us? Well, rather than giving into abstract existential fears, we really need to focus on physical reality and adaptation. One major step in maintaining control is keeping the AI local, rather than relying on massive, power-hungry cloud data centers. MIT has made a huge breakthrough here with what they call liquid networks. Inspired by the microscopic C. elegans worm, which operates on just 300 neurons, researchers built a neural network that operates on just 19 liquid neurons. 19! This hyper-efficient brain is smart enough to be deployed directly onto edge devices, like an autonomous car, allowing it to navigate brand new environments entirely on its own, without even needing an internet connection to the cloud. And perhaps the most beautiful example of this human-machine partnership we saw in the source material is in the realm of prosthetics. The research features an incredible story of a subject using an AI-powered bionic arm. Here is how that messy, vital partnership actually works.
The user imagines the movement of their phantom limb. This causes faint EMG electrical signals to fire in their remaining muscles. An AI algorithm on the arm, called a Bayesian classification model, reads those faint patterns and matches them to an intended movement. But the most important part? It's not just the machine learning. The human and the algorithm learn together, adapting to each other over time to restore incredible physical function. Which brings us to the end of our explainer today, and really to the ultimate question we all have to answer. The AI revolution is not some Hollywood movie anymore. It is a profound tool that is already here. As we step into this great unknown, will we take the responsibility to establish the guardrails and the understanding necessary to ensure these incredibly powerful machines remain our partners? The door to the revolution is wide open, and what happens next is entirely up to us. Keep learning, keep questioning, and thank you so much for joining me to demystify the AI revolution.